All right, let's talk about validity. Luckily, this is a sort of less technical sort of topic. And hopefully we can get through it pretty easily. It's fairly understandable. So the problem with defining validity is that there are lots of different ways people think about validity. So, all right, so validity in terms of measurements is the extent to which a test measures what it was designed to measure. So this is sort of like that it's sort of on target. You develop a depression inventory and it actually measures depression, okay? Which is different, separate from reliability, which is a measure of how well or how consistent a scale is, okay? So agreement between a test score or measure and a quality or trait is believed to measure, all right? That's what we're targeting here with validity. There's a proliferation, love that word, of definitions that led to a dilution of the meaning of the word into all kinds of different validities that people use often. That's why it gets confusing, not because they're not validities, just because there's so many and it becomes sort of difficult to parse them apart, okay? So when talking about experimentation, you've taken classes on experimental design, like 100B at UCLA or at CSUN at Psych 321. We talk about things like internal validity, external validity. So internal validity, it really has to do with freedom from confounding variables. You want a clean relationship between your IV and your DV. So you get a cause and effect in an experimentation. So you have high levels of control and you eliminate any confounding variables, usually by holding them constant and just sort of getting rid of their influence. That's internal. And most classes on experimental design will spend a lot of time talking about how to increase internal validity, because that's oftentimes the goal, is to create a strong relationship between the IVs and DVs, or IV and DV, as possible, so you have a clear sort of relationship. Now, the flip side of that is external validity, which these are the two things that get talked about a lot in experimental design. External validity has to do with, as we take samples from a population, got a population of people, right? Got this huge population of people here, right? Their population, and we take a tiny little sample from there. We want to be able, we want this to be representative and all that stuff. External validity has to do with how well, I'm going to use a different color, we're able to infer meaning and have it generalize back to the population to make this sort of inference. How well it applies to everyone, how well whatever happens in the sample applies back to everyone in the population. So it externally predicts or represents what's happening in the larger population, or in a sense, how much this sample represents what will happen in other samples coming from the same population, that it externalizes, it generalizes to other samples and to the bigger population. So to what extent one may safely generalize the findings from an experiment, right, to from one sample studied to the population, or to other populations, other samples, etc. That's what it's about, generalizability. And sometimes this is referred to by there's other sort of forms of it, like population validity. Can the sample results be generalized to the target population? Ecological validity, whether the results can be applied to real life. Can it generalize outside of the laboratory? Can we actually take the findings that we get from a study and replicate them, actually see them happening in real life? If you do a very controlled, very artificial, very sterile experiment in a laboratory, you may find it has very high internal validity, but it may lack in this sort of ecological validity, like real life. It may lack some realism, and you may not find the effects as clear in the actual population out in real life. I feel like this is what it'd be like if you're getting getting a lecture by the guy washing the windows outside your building. Like, yeah, so it's, you know, anyway. So in terms of experiments and research design, this is like oftentimes seen as sort of the crown jewel, the thing, this cause and effect relationship tends to drive a lot of the choices people make in terms of experimentation. And there is a trade-off that oftentimes the more internally valid something is, the less externally valid it is, and sort of vice versa. Because the more sterile and controlled it is, the less ecologically valid it is. It's going to not generalize very well to back to the population or back to other samples, etc. Okay. This is not the kind of validity we're talking about. This is the kind of validity that's talked about quite often in research methods, and in general, it's talking about the same kind of thing. How well does the experiment that you're doing reflect reality, or reflect reality, that sort of external validity, and how well does the thing you study actually cause a relationship? Can you actually show that that relationship is real? So it does reflect this idea of, is what you're doing really reflecting sort of reality? And that's what, why that's why validity tends to take many forms. They're all talking about the same kinds of things, but it can get kind of confusing. So in terms of scales, there's all kinds of stuff that people have come up with. Content validity, right? So when trying to measure a domain, or all subdomains represented. So measuring depression, are all 16 clinical criteria represented in the items. I think the 16 I think is referring to is from the DSM. This may have been dated. This may be 16 from the DSM-4. It may have changed in the revised version. But anyway, are all the clinical criteria represented? It's very complementary to domain sampling theory and reliability. However, often high levels of content validity will lead to lower internal consistency reliability. We talked a little bit about that in the previous lecture, where the more complex a scale is, more subscales, more types of content covered, the less likely the items are actually going to be internally consistent, because they're really reflecting different pockets of items. And within each pocket, you may have high internal reliability, but across all the items, it can actually make it hard to find them to be internally consistent. Then you have content validity. Is it really reflecting the content? Is it covering all the content supposed to be there? Then you got construct validity. Overall, are you measuring what you're intending to measure? So this is like, are you on target? So when we talk about validity in terms of measures, in terms of scales, this is oftentimes the one that's being referred to. Are you actually measuring the thing you're supposed to measure? So you have intentional validity as part of this. Are you measuring what you intended and not something else? Sometimes people will intend to measure depression and end up getting some anxiety in there, or end up measuring something else. So for instance, in terms of differentiating between reliability and validity, I could give people an anxiety measure and show that that anxiety measure is reliable. Do test-retest reliability, internal consistency, like Chromebox Alpha. But if I was intending to measure depression, then that anxiety measure, though reliable, is going to have poor validity, or at least poorer validity. Okay, then you got representation validity or translation validity. How well have the constructs been translated into measurable outcomes? This is really talking about the validity of your operational definitions. Were the constructs operationally defined in a way that makes sense, that people agree on, that it seems to represent the items or the intended constructs sort of accurately? Then you get this idea, people will throw out this idea of face validity as a form of construct validity, and argue that this really isn't. But face validity is like looking at the face value. Do the items appear to be measuring depression, measuring the thing you're intending? So do questions about depression have words like sad or depressed in them? Because if they do, then it has sort of high face validity. But there's something to say for the fact that face validity can actually sometimes be problematic. If you tell people exactly what you're measuring, sometimes you get different responses, because they'll give you the response they think you want, as opposed to the truth, and really getting at their true score on that scale. So face validity can be very problematic, and oftentimes high face validity will actually hurt the scale and make it sort of not very usable, not very, just not very good. Okay. Then there's all kinds of other types of construct validity. There's observation validity. How good are the measures themselves? It's akin to reliability. You got convergent validity. Convergent validity refers to the degree to which a measure is correlated with other measures that are measuring the same thing. So convergent validity talks about if I'm developing a depression inventory, then it should have a high correlation with other inventories like the CESD or the back depression inventory, right? So they should converge. They should all be showing that they're measuring a similar construct. In the same way, you have discriminant validity, that if I'm measuring something like depression, it should discriminate from measures that are doing something like anxiety or quality of life or some other type of scale. It should actually be different. It should actually have a low reliability or low correlation with those to show that it's actually measuring something different. So discriminant validity describes the degree to which the operationalization does not correlate with other theoretical things, other constructs, other operationalizations that it should not correlate with. Okay, so you want to show that it relates to things that it should relate to and doesn't relate to things that it shouldn't relate to sort of be able to tell what it is similar to and what it's different from, as a way of showing how it converges and how it discriminates against different types of constructs. All right. Then you got criterion-related validity, the success of measures used for prediction or estimation. Now this is interesting because this goes a little bit beyond just this actually gets at sort of the utility of the measure. So instead of just thinking about are you measuring what you intend to measure, it's really asking, is the measure actually useful at doing things like predicting someone's scores on another scale, or showing concurrent validity with other things that are being measured at the same time. So there are two types of criterion-related. So you got concurrent validity, the degree to which a test correlates with an external criteria that are measured at the same time. Now notice I'm saying external criteria. So this is not another measure of the same type. So that's convergent. So if I have a depression inventory and it measures, and I correlate that with another depression inventory, that's convergent validity. Concurrent validity is whether or not you can compare it to an external criteria, like does scores on a depression inventory predict someone's suicide ideation, or someone's attempt at suicide, or someone's hospitalization in a psychological care facility, right? A better example is things like the SATs. You'd want SATs to have concurrent validity with current high school grades. So if I take the SATs and I get a high score, you'd imagine that should be concurrent with high GPA. GPA being a criteria, not another measure, not another scale, but an objective sort of criteria that's external to the scale, the thing you're measuring. So you got SATs as an aptitude sort of measure, and it should correlate concurrently with things like GPA. But it should also have predictive validity. So concurrent means it actually should relate highly with things that are happening at the same time. Okay? Where predictive validity should then predict stuff that's going to happen in the future. So SATs are supposed to predict sort of success in college, university. So you would expect that SAT should correlate highly with college GPA, things like that. Success in college, however you want to, like graduation rate, something like that. And they've shown some very strange statistics about it. Like it predicts a person's first semester GPA fairly well, but then after that, it's not very good at predicting much of anything in terms of college success. Example here too, looking at concurrent validity, does a depression inventory, like the back depression inventory, CESD, correlate with a clinical diagnosis? So what that means is if you send somebody in for a clinical interview, they go to see a psychiatrist and they give them a clinical interview and they go through the process of diagnosing depression does the CESD, or the back depression, that kind of stuff, correlate highly with those diagnostic sort of criteria used by the DSM and by psychiatrists and psychologists to sort of diagnose those things? That would be concurrent, where the predictability would be like someone takes a depression inventory now. Does that actually predict a later clinical diagnosis? So the difference between those two is that one is happening at the same time, the other one's happening sort of in the future. Then you got something like that's called social validity. It refers to the importance and acceptability of a measure. So this again goes to the utility. If you create a measure and it works really well and it has good reliability and validity and all this stuff, but it's either in a construct that no one really cares about, or it's done in such a way that doesn't seem to be useful for most people, and people don't really want to use it or don't like it, then it's not a very valid measure because no one's really going to want to use that scale. So this is sort of the social validity of it. So there is a total mess of validities and their definitions that we've just sort of covered. There's all these different definitions, and there's even more. It goes on and on and on. There's all kinds of definitions of validity, and I went through a lot of those just to give you an idea of just how complicated and messy this ideas of validity get. So by 1985, there's a joint committee of the American Education Research Association, the APA, which is the American Psychological Association, and the NCME, which is the National Council on Measurement and Education, developed standards for educational and psychological testing, which was then revised again in 1999. The idea is to try to come to some agreement about many of these validities that oftentimes seem and sound like they're just repetitive. So trying to figure out that there's a way to sort of classify these validities in ways that actually make more sense. So according to the Joint Committee, validity is the evidence for inferences made about a test score. All right, so they tried to figure out a general definition. What kind of inferences can you make about a test score? If the inferences can be made more directly and they're more trustworthy, then that scale is said to have more validity. So there are three types of evidence. Now, some of these are things we've already sort of seen or talked about before. But they're just reorganizing them that all the other ones sort of fall underneath that. There are three types of evidence that you can have. So instead of thinking about content-related validity, we're now talking about content-related evidence for the validity of a scale. So it's semantics a little bit, but it's different from the notion of different types of validity, which is different types of evidence for showing that a scale is valid. All right, so it's a way of sort of reorganizing this, so it's not so many different kinds of validities. Really, validity is one thing. It's the evidence for inferences made about a test score, right? So a score is valid if you can make inferences about that score. So how do we show this evidence? Well, there's three different kinds: content-related, criterion-related, and construct-related. This is different from the notion of different types of validity, and now we're getting at just different types of evidence for validity in general. All right, so there are three different kinds. You had content-related validity, content-related evidence, based upon analysis of the body of knowledge surveyed. So this usually requires experts in the field to sort of decide that these things are there. So like using the DSM to figure out the criteria, the different types of criteria required to look at depression, is looking at sort of content-related evidence. Then you have criterion-related evidence, which is based upon the relationship between the scores on a particular test and performance or abilities on a second measure that is sort of more concrete, that is a criteria that you're using to sort of show that measure relates to. Again, looking at SAT and GPA, okay? Depression inventory score and a clinical diagnosis by a psychiatrist. Okay. Then you have construct-related evidence, which is based upon the investigation of the psychological constructs or characteristics of the test. All right. So this is now looking at additional evidence about the test itself, and we'll talk more about these as we go forward. So let's talk about. So one of the things they made clear is this idea of the validity that isn't really validity, right? So face validity is not really test validity. So the mere appearance that a test has validity is not enough. It actually could be counterintuitive. Does the test look like it measures what it's supposed to measure? Do the items seem to be reasonably related to the perceived purpose of the test? Well, those things often aren't enough. And if you take in some psychological inventories, you realize that some questions don't seem to be at all related to the thing you're trying to measure, and yet they relate highly. I'm trying to think of one. Like in depression, it oftentimes will ask about, have you gained or lost weight in the past 5 weeks or something like that. So look at weight loss or weight gain in and of itself doesn't seem to be super, like on the face of it, doesn't seem to be super related to depression, and yet it is. So does a depression inventory ask questions about being sad, right? This is not a real measure of validity, but one that is commonly seen in the literature, that they'll claim that a test is valid simply because it looks like it is. So it's not considered a legitimate form of validity by the Joint Committee, and it's considered not real validity. Okay, so that's why it's not one of the 3 types of evidence. All right. So let's talk about those. Content related. Does the test adequately sample the content or behavior domain that is designed to measure? If items are not a good sample, the results of testing will be misleading. So sometimes they refer to this as sort of bandwidth, that certain measures, certain constructs have a wide bandwidth. Like depression is one of those. There's lots of different kinds of ways in which depression manifests. And so a scale needs to be inclusive and cover the complete bandwidth of that scale. If it doesn't, if it only includes a narrow bandwidth of items, then you're not getting a full range of measuring depression, and the results could be misleading. Usually developed during test development. This is at the very beginning. It's not generally empirically evaluated. It's not something that we look at and say there's a measure for that, a Chromebox alpha or something like that to measure the content related evidence. It's really more subject matter experts, clinicians decide on, like people who develop the diagnostic and statistical manual, the DSM. They go through and decide what the clinical criteria are for depression, and then people will develop questions or tests based on those criteria as a way of looking at content-related evidence. Okay. So to develop a test with high content-related evidence of validity, you need good logic. So you need to be sort of logical about what needs to be included and what doesn't. That's why you need to have these sort of you need to have content experts in the field so that you actually can cover everything. You have some intuitive skills because you need to be able to figure out ways of measuring, getting at certain criteria without making it super obvious. So you need to try to avoid face validity to a certain degree and have sort of more intuitive questions that sort of get things going on there. And you need to have, among all things, perseverance. When you're first developing a scale, trying to find items that all go in the scale and trying to put things together, it's a very long sort of iterative process. You sort of make a scale, it looks like it doesn't work very well, you add more items, you change wording. You have to go through many iterations of things before you can actually get something that really works. It's a very complicated process. If this class had been larger, we had more students in it, my intention was to actually make a scale, to develop questions, do it, to actually show you just how sort of complicated making a scale is, and going through the process of at least one iteration of sort of figuring out which items worked and which did not. But it's not really realistic for the current session. But anyway, when developing this stuff, you must consider a couple things too, like the wording of items. You got to make sure that you don't include like double barrel language, which means you're asking 2 questions in one question. So if someone answers to that, you don't know which part of it they're answering, or misleading questions where you make it perfectly obvious to the respondent which response you're really looking for. Like instead of asking like on a scale of 1 to 5, what do you think of the job that Donald Trump is doing as president? Right, that's a little more sort of neutral instead of saying how much do you agree that Donald Trump sucks as president? It's a misleading question that you're sort of telling people sort of how do you think they should be responding. The same thing with double barrel questions is, if you're asking questions about depression, if you say something like, I often feel sad and rarely leave the house. So if they, scale of 1 to 5 or whatever, they actually rate that highly, are they saying, they agree that they feel sad or that they don't leave the house? Do they have to agree to both? So oftentimes want to avoid complex questions, which is why most scales have very short, simple statements that you agree to, or short sentences or questions, because they're trying to avoid sort of include too many topics in one thing. You also need to think about reading level. Look at sort of what the average reading level that most people that are going to be responding to the scale, what that reading level is, and sort of target that. You can't write everything with a college level vocabulary. You may need to think about, I think it's like 7th or 5th grade or something. You need to think simple language, very straightforward. And this is even more so if you're gonna be trying to include children in the sample that you're trying to measure. Like if you want to develop a depression inventory for children, then the reading level needs to be even lower to make sure that they can understand the questions and answer in a corresponding way. Other content-related evidence terms like construct underrepresentation. So we're going to talk about bandwidth. Okay, so if you're not quite covering all the bandwidth, right, then failure to capture important components of the construct would be then an underrepresentation. So if there are 16 clinical criteria for depression in a DSM and you're only covering 4 of them, you're not representing, you're underrepresenting the construct. So think about in a class, the test is designed for chapters 1 through 10, but only chapters 1 through 8 show up on the test. There are 2 chapters you studied for no reason or something like that. Then there's an underrepresentation of the material in the test. Okay, and you also got construct irrelevant variance. Occurs when scores are influenced by factors that are irrelevant to the construct. Meaning that you're including items or there's information in the test that could be measuring other things. This happens a lot with, like when we talked about depression. You're trying to measure depression, but it's getting, there is variability and influence from people's levels of anxiety that are creeping into depression inventory. So you're getting construct irrelevant variance. You're getting variance from anxiety that's interfering or adding on to the variance in depression, and that can add more sort of to the measurement error. So test is well intentioned, but problems secondary to the test negatively influence the results. Things like reading level, vocabulary, unmeasured secondary domains, meaning that there's, like, again, you're measuring depression, but a secondary domain like anxiety is influencing their scores. Now, there's something interesting, the reading level and vocabulary. So one thing people don't take into account a lot, I mean they do, but I think the general public doesn't think about, is that we talk a lot about math ability in children and even in adults and in college students, that someone's math ability, like your ability to apply equations and solve problems in mathematics, depends highly on your reading ability. So your reading comprehension, vocabulary, have a huge impact on your ability to read a math problem and decide how to sort of tackle that problem and solve it. So if you have poor reading ability, that can actually add variability negatively and negatively impact your ability to capture someone's math ability on a math aptitude or something test. So there could be other factors that are greatly influencing your intended target construct that, if you don't address it, may actually be causing variability and making the reliability and validity of the test seem worse, when in fact it's being influenced by outside factors, outside things. So now switching over to criterion-related evidence, this tells us how well a test corresponds with a particular criterion, usually something that's behavioral, or it's a measurable, sort of more concrete measure, indicator of the thing you're trying to measure that is not a scale. All right, so like I said, SAT predicting GPA, where GPA is the criterion. BDI scores predicting suicidality, where suicide ideation or suicide attempt is the criterion. So it's used to predict the future or predict the present. And we talked about that before. The word criterion-related evidence is either concurrent or predictive. And that's what I mean here. It's either going to predict your future scores on something, which is oftentimes harder to do, or at least concurrently. It's going to concurrently predict the behavior or measures on some external criteria. Okay, so you got predictive validity evidence, which is what people oftentimes will focus on. Things like the SAT scores should predict your success in college. So SAT predicting first year GPA score. If your GPA, most tests don't have great predictive validity. It's very hard to sort of do that because people change. There's growth, maturation, things that occur between high school and college that may change things, may change people's focus. You may be very highly motivated in high school, get to college and decide you don't like it and don't try very hard. So it lowers the relationship and sort of vice versa. And the farther apart things are, the farther into the future you're trying to predict, it's going to show less and less of validity in terms of predictive validity, because the farther apart those times are, the more difficult it is to show to show that prediction. Concurrent validity is sort of usually easier to establish because it's happening at the same time. So it's really forecasting the present. That sounds weird, but you're predicting people's behaviors or their outcomes, their criteria, that's happening at the same time that the scale is being measured. So how well does the test predict current similar outcomes? So job samples, alternative tests used to demonstrate concurrent validity evidence. So job samples, meaning that, oftentimes, if you've ever gone into to apply for a job and they give you like these sort of inventories to look at personality, all kinds of other stuff to try to see how good of a fit you are. They're trying to predict mostly sort of how you fit right now concurrently with the job you're intending to do. And I guess it's, also to predict your sort of future success in the job. But, they're trying to figure out if you're going to be successful, and they're looking at sort of your concurrent behaviors, things that are actually, they look at, people apply with these certain criteria, with certain response patterns to these inventories and how well they do at the job. They're trying to apply that and see if you actually be a good fit as well. So generally higher than predictive validity estimates because they're happening concurrently. So at least you're getting responses from the person at the same time. So they oftentimes have a higher validity rating because of that. So quantifying criterion-related evidence. So we can actually compute validity coefficients the same way we do with reliability. So if we actually find a criterion to use, which sometimes can be difficult to have an external concrete criteria, correlation between the test and the criteria will tell you how valid it is. Usually between 0.3 and 0.6 in real life. In general, as long as they are statistically significantly related, the evidence is considered valid. So remember that usually between 30 and 60. So this is not as high as reliability. So if I give someone a measure of depression and look at their clinical diagnosis from a psychiatrist, I'm not looking at it to be at the same degree of relationship, 0.8, 0.9, as we do with reliability. We actually consider it to be fairly valid as long as it can actually capture a significant amount of the variability in the criteria, or criterion. However, recall that it's supposed to be R squared, not R2. R squared indicates explained variance, so in reality, we are only looking at explained criterion variance in a range of 9 to 36%, really, if we square this and square that, right? So we're looking at 9 to 36%. I'm saying that sound problematic. It seems like we're putting the cutoff for reliability fairly high. When it comes to validity, we're got a fairly low bar on what is considered sort of valid, or at least a indication of a valid measure with criterion-related evidence, right? So again, still evaluating criterion-related evidence. Look for changes in the cause of relationship, oftentimes a third variable effect. So situational factors during validation that are replicated in later use of the scale. So what the hell does that mean? So sometimes a person's depression inventory score and their, say, clinical diagnostics with a psychiatrist may be highly related because especially if it's concurrent, because there was recently a death in their family that's triggering sort of both of those things, making them seem more related. The same thing with, I think of like, GPA and SATs and GPA. It's not really a good example of third variable. I can think of that. I can't really think of it. I think it's because I've been talking for a while and my brain's starting to shut off. But this idea that there are oftentimes other factors, other things that could be contributing and predicting both the scale and the criteria and making them seem more related. Examine what the criterion really means. Ultimately, the criterion should be something the test is trying to measure. If the criterion is not valid and reliable, you have no evidence of criterion-related validity. So that's another way of saying if your criterion is bad, then trying to establish the criterion-related evidence for the scale is not really going to work very well. Again, we learned that things with poor reliability don't correlate very well. So if you have a criterion that has a poor reliability, you're not going to be able to correlate with it very well. It's going to look like your scale has poor reliability. Poor validity, I mean. Review the subject population in the validity study. If the normative sample is not representative, you have little evidence of criterion-related validity, at least as it applies to the general population. It may have criterion-related validity for that specific sample or that specific subsample of people in that sample, but in general it won't, because it had a narrow bandwidth for the people that it was representing from the population. Ensure the sample size in the validity study was adequate, right? So oftentimes, we're trying to establish correlation between things. We gotta have enough power, enough people in the sample to ensure that there's representation, but also so there's enough power to sort of find a correlation if it exists. And also never confuse the criterion with the predictor. So GREs are used to predict success in grad school. Some grad programs may admit low GRE students, but then require a certain GRE before they can graduate. Think about that for a second. So we admit you with a low GPA, a low GRE score, but then before you can graduate, before our marker, our criterion of success, which is graduation from graduate school, you have to retake it and get out. So then it looks like, so low GRE scores succeed and actually go on to say PhD programs or other things because they retook it. So people with low GREs do well, which makes it seem like it's not a very strong relationship between the test and the criteria or criterion. But it's sort of a goofy process in the first place. If you're admitting students into your program based on things other than GRE, while you're then requiring the GRE to graduate, it doesn't make a whole lot of sense. Unless the goal of the program is to try to get students into the next graduate program, like going from a master's to a PhD or something like that. And also watch out for restricted ranges. What that means is that if you're only looking at, this happens a lot with SAT scores and other things too, but oftentimes the only scores you have for students who are actually in the university, and it goes for GRE too, oftentimes are people who scored high on the GREs. They get in, you look at the success between the GREs and the relationship between the GREs and the success in grad school, and it looks like there isn't one. Well, it's because you're only looking at all the top scoring GREs and their success. So it looks like there's very little variability that matches because the bottom of the GRE pool isn't there. So let's look at, if you think about admitting everyone to grad school, right? And there's some certain cutoff for GREs. I don't know. Let's say it's 1100. Right, so you gotta have 1100 on a GRE. It's actually not even scored that way anymore. It's making up a number. And then you have sort of, let's say there's some kind of continuous measure of success in grad school. So this is success, and this is sort of GRE. So if you have people that are really low, that are not succeeding, and you have people who are really high succeeding, then it's going to look like your test relates to your criteria perfectly well. The problem is these people don't exist. Now you actually have a much smaller range. Maybe they might take someone, a couple people a little under their cutoff, and then everyone that is above that criterion succeeds. There's no variability, there's not enough variability for them to show that there is a relationship between the criteria and the test you're developing with something like the GRE. So this, even though I complain a lot about the SATs not being very predictive, this also is what happens with the SATs. Students that take SATs tend to go on, if they do well in the SATs, they go on and they're successful in the university. Students that don't take the SATs or do really poorly in SATs end up not going, or they go a different route, go through community college or something else, but they don't end up going directly to a four-year university. So you have a very narrow, restricted range of SAT scores and then success, and there's not enough really to really indicate a correlation. So it looks like it has poor criterion-related evidence, when really it's due to sort of truncation of scores. You have to have enough variability in both to show that there is a correlation between them. If you're only looking at a small little range of things here, it's going to look like there's no relationship between them, because you've actually only looked at a small window of people and their relationship between GREs and success, or SATs and college GPA or something like that. So that's one of the issues. You'd have to let a bunch of people into grad school who had low GREs to show that they didn't succeed, right? Which is not, seems sort of weird, but you want people with low GREs to go in and then do poorly. If you do that, then you start to have this range of scores on both sides. You can show there's a relationship between the GRE and success in graduate school, but it's just not how it works. So that's why it looks like there's less relationship between the predictor and the criterion. Review evidence for validity generalization is another sort of evaluating criterion-related evidence. Tests are only given in laboratory settings and expected to demonstrate validity in classrooms. Probably not going to happen. Look at their ecological validity. Does it seem to be predicting things that are going on in real life? Is there some reality to what's happening, or is it just some very specific laboratory developed sort of scale that only relates to the criterion in a lab controlled setting? Consider differential prediction. Just because a test has good predictive validity for the normative sample may not ensure good predictive validity for people outside of that sample. All right, so when you start to change, when you use, say, college students as your normative sample, and you want to then go to other adults or non-college attending adults, so you want to take it to adolescents, it's very likely that when the relationship between your scale and the criterion is not going to be as strong. If it was developed for college students, when you go outside of that population, it's probably not going to work very well. This sort of relates back to external validity. How good can we generalize back to the population we're trying to measure, and who is our intended population in the first place? Oftentimes there's a mismatch there. People will develop scales to measure depression in everyone, in adults, but then they only develop it using college students because they're readily available. They're taking intro psych and they get credit for participating in studies, so that tends to be their normative sample, and then they wonder why when they take it outside of that, it doesn't work very well for other adults. It's because it doesn't have very good external validity that way. Okay, so we talked about content-related evidence, criterion-related evidence. Now let's talk about construct-related evidence. So construct is something constructed by mental synthesis, right? So we always talked about, construct is sort of a goofy, concept. Constructs are sort of hard sometimes, like what is intelligence, love, depression. All these things are sort of constructs. So construct-related evidence is assembling evidence about what a test means and what it doesn't. So a sequential process of sort of testing and editing into an iterative sort of sequential process generally takes several studies to sort of show, right? So you use sort of content-related evidence to sort of develop the content. You use construct-related evidence to sort of then develop that and fine-tune that content so that it actually is measuring what you want. So it's again, it's a sequential process. Usually takes several studies to sort of identify this stuff. So you got this. This would sound familiar. We talked about this earlier. We got convergent and discriminant evidence. So the convergent evidence is obtained when a measure correlates well with other tests believed to measure the same construct. So oftentimes these are like self-report kind of things. You got collateral report measures. So you give someone the Ainsworth depression inventory and the Beck depression inventory and the CESD to show that my scale correlates highly with both the CESD and the Beck depression inventory. That shows convergent evidence for validity. With discriminant evidence obtained when a measure correlates less strong with other tests believed to measure something slightly different or more, different than what it is you're intending to test. This does not mean any old test that you know won't correlate. Like, don't just throw in anything. Like if I'm trying to measure depression, I'm like, let's throw in shoe size, right? It's not about just throwing any measure in there to try and show it doesn't. But what you want to do is if you're trying to develop an IQ test, so an IQ test is going to relate somewhat to achievement tests, but they shouldn't relate to achievement tests as much as they do to other IQ measures. And in measuring intelligence should be different than some measuring achievement. There should be some discrimination between those two things if the scale is really measuring IQ and not achievement. So you're trying to show how these things can differentiate between scales, between different constructs. So validity and sort of estimates. By the way, go back a second. So oftentimes, we're using things like correlations in the same way we did with the criterion-related evidence. We're looking for the correlation between things to look at the convergent evidence for validity. We're looking at lower correlations to show discriminant evidence, right? So this is the same process we're using for reliability. Or we're looking at a measure compared to another measure, like parallel forms. But instead of being parallel forms of the same scale, we're now using the scale that's developed relative to other scales measuring the same thing to show some correspondence. And that's a sort of convergent evidence. Or with other scales measuring other things, like if you're developing a depression inventory, using things like anxiety or other measures to show that there's less of a relationship between your measure and these other measures. But we're still using things like correlation. So how things get affected by this. So we went back to that sort of standard error of estimate from before, and this is it's sort of looking at regression all over again. It's how does one thing predict from another, and still this idea that you take your standard error of estimate, you're trying to predict one scale from another. You can figure out the standard error of estimate, which is this. Take the standard deviation of the test that you're looking at, right? Which is the sort of just treating it as y. We've got the reliability of the test, which is that r. I think it's not supposed to be a square here, I don't think. It's just 1 minus r, 1 minus the reliability. And you multiply that by n over 1 divided by n minus 1 over n minus 2. And it essentially gives you an idea of the standard error of estimate that you get in a regression. I sort of mentioned this because this actually gives it an idea of sort of you can use this reliability estimate to then figure out how well can we actually predict this particular scale. And this is the main point I want to make is that, and I mentioned this before, is that validity depends, it's kind of funny to think, validity relies on reliability. Validity depends on validity. So if I'm trying to take, again, two scores, my depression inventory and the Beck depression inventory, and I want to show that there's convergent validity, the reliability of each of those scales is going to impact the amount of validity I can actually find. So we need to figure out what's called the max reliability. This R12 max is essentially we take the reliability of measure 1, reliability of measure 2, like my depression inventory and the Beck depression inventory, and I'm going to multiply them, take the square root to give me what the maximum validity would look like. The maximum validity being restricted by the product of the two correlations or two reliabilities. All right, so we're going to figure what that is. And then once we figure that this is the max reliability we can have, this is where that sort of correction for attenuation comes, right? Where we can actually correct for attenuation. But in lots of cases like this, we don't necessarily want to do that. But we could figure out what the validity would look like if both measures were actually measured perfectly without error. So we can correct for attenuation when calculating the validity of a test as well. But this idea is that the reliabilities represent the maximum validity you can have. So that's an interesting thing. There's a limit on the validity based on the reliabilities of the two scales that you're trying to use in convergent validity. So to think about that, this may be a little small, but right. So if both tests are at a 1, meaning perfectly measured, the maximum validity you can have is 1. But let's look at here we have this test is measured at a 0.8 reliability. That test is measured perfectly, and we get, so this is saying criterion, but this really could be another test as well, because oftentimes the criterion is seen as being measured, because it's a concrete external thing, it's seen as being measured perfectly, but this could be another construct, right? So if I have a scale, let's say 0.6, this one's 0.1, the maximum validity I'm going to have is a 0.77. That's the most I can get. So you can see as we go through this, the combinations here, all right, if there's no reliability, obviously there's no validity. Okay? If my test is really highly reliable, I got a 0.8, but my criterion I'm measuring it along with has only a 0.2, it's going to have a crappy validity. Right? The maximum validity is actually going to be very low. So you can see this all sort of depends. The reliability of your test and the criterion, or your test and another construct, are highly dependent on the reliabilities when actually calculating the validity. So validity is dependent on reliability. So another way of saying that is a measure can be reliable and not valid. Okay, so you can have a measure that's perfectly reliable but not valid. So think about it as, again, I develop a scale to measure depression, but I'm confused and all the items really are asking about anxiety. So I give it test retest, high reliability, but it's not measuring depression, so it's not valid. Okay, so it can be highly reliable and not valid. However, if it's not reliable, if you have low reliability, it can't be valid. Right, there's no validity without reliability, but you can have reliability without validity. Validity depends on reliability, but not the other way around. All right, I think that's all I got to talk about for this sort of supplemental stuff, just to make sure I covered it. And hopefully this helps, helps make some sense of all this stuff. Again, send emails and things if you have questions about stuff I covered in here. If not, that's it. Take it easy.